Hello and welcome to Mr. Davis's Math Classroom. This is Algebra 1 and we're on Lesson 6.2 today, which is solving systems using substitution. Now hopefully you've had a chance to work on the warm-up and you're ready to go. So the vocab that we're doing today is the substitution method, and it's not just a vocab word, but it's a method. Now this is the way that you can solve linear systems by you solve for one variable and then substitute into the other equation. Now I have 5 steps here that can help you if you have trouble remembering all the steps, right? Which is choose a variable, solve for that variable, substitute into the other equation, solve for the variable, substitute in the number into step 2, okay? Which isn't as bad as soon as you get the hang of it. All right, so go ahead and take a minute to write that down, and then we'll move forward. So right here, we're going to solve the system using the substitution method. Now, step 1. All right, so step 1 says to pick a variable. Now we actually have 4 variables to pick from. We have 2 y's and then 2 x's to choose from. Does not matter which one you pick, you will get the same answer, but sometimes picking a variable can make it easier on yourself. All right, so for step 1, I'm going to go ahead and pick this y right there. The reason why is because it's already by itself, and it'll make step 2 a whole lot easier. So that's step 1. Step 2 is to solve for that variable, which means I want to get it by itself. If we look, it's already by itself, so step 2 is already done. And that's why I picked that y as my variable. All right, step 3 is to substitute into the other equation. So since I used the top equation, I need to substitute into the bottom. So basically what I'm going to do is I'm going to take, and I'm going to write it down like this every time, okay, where I just put parentheses, a big parentheses around where the y should have been. Now, since I solved for y, I'm going to put parentheses around the other y. Inside, I'm going to write what y is equal to. Well, we know y is equal to 3x. So that's step 3. Step 4 is to solve, which means I have x plus 3x is 4x, and that's equal to negative 32. Divide by 4, we get x is negative 8. Step 4 is done. And step 5 is to substitute into the other variable, or the first equation, and then solve. So step 2 said to solve, right? So this was my step 2 equation right there. That's where I'm going to plug this number in. So I'm going to say y is equal to 3 parentheses negative 8, which gives me negative 24. So my solution are those 2 numbers. Now, remember, we have to write them together in an ordered pair, which looks like negative 8 minus 24. And that's step 5. All right, well, that's substitution method, using the 5 steps to get the answer. Has some advantages over graphing, which we learned last time. One is you don't ever have to guess about where they cross. You will always get an exact answer. You might not like it because it's a little bit more arithmetic and a little bit more steps and graphing them, but it's a good method to get an exact answer. And plus, if you look at the answer that we got right here, we would have had to make sure our graph paper went to negative 24 in order to even see the solution. So sometimes when the solution has really large numbers, it might be easier because you won't have to adjust your graph paper for that. All right, here's one for you to check. Try by yourself. If you need help, refer to your notes in the previous problem. All right, so here we're going to do another problem. If we think about this one, step 1 is to choose a variable. None of them are going to be quite as easy as last one, because last one already had a variable that was solved. But out of all these, I think I'm going to choose that y. Because there's no number in front of it, it's going to save me about 1 step. Step 2 says to solve for that variable. So if I write it down over here, if I solve for that variable, I'm going to get add 2x, get y is equal to 2x minus 3. So that's step 2 now. Step 3 says I'm going to take this and I'm going to substitute it into the other equation. Since I solved for y, I'll put parentheses around y. Notice I left the 3 on the outside. Basically, we're going to get a distributive property here. 2x minus 3, so y is equal to. Now, step 4 says to solve, so we're going to go 6x minus 9 plus 4x is equal to 14. If I combine like terms with the x's, I have 10 of them, 10 x's. And then to get x by itself, we need to add 9. We get 10x is equal to 23. Divide by 10, x is 2.3. Nice. Now, last step was to take that and plug it into step 2 equation, right? So that's that piece. We're going to plug it into step 2 equation, which was right here. So we get y is equal to 2 times 2.3 minus 3, which is 4.6 minus 3, or 1.6. Last step, let's go ahead and write it in an ordered pair. 2.3, 1.6, and that's my solution. Now, if we look at this one, we would have been probably pretty hard-pressed to get that exact answer if we would have graphed it. As a class, if we would have graphed it, if we had 30 people graph this, we probably would have had, most people say 2.5, 1.5. I'd be surprised if one person in the class guessed the right answer from graphing. Now, substitution method, we got an exact answer. We know exactly that we're right. There's no guessing involved. So that's the positive to this method. Here's one for you to try. Make sure that you pick the right variable and then solve. All right, here we have a system of equations, but it's a word problem this time, so we need to come up with our own system of equations. So let's read. A snack bar sells 2 sizes of snack packs. A large snack pack is $5, and a small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs does the snack bar sell? Well, we've been dealing with systems of equations, which is 2 equations with 2 variables. Right? So our 2 variables here, right? It's always nice to know what my variables are. My 2 variables is going to be the large snack pack, which I'll call x will be the large, and then y will be my small. Now you could choose any variables. You could use L and S if you wanted to, or any variables that you like. I'm going to use the x and y. All right, now when solving for in word problems, one useful tool is to always look for totals. Okay, totals. There should be totals that will help you. So the first total I see is right here, 60. 60 is a total, so 60 is a total. Well, that's how many they sold. Well, how do I get 60 sold snack packs? I must add the large snack packs sold plus the small snack packs sold. And that should give me the total there. The other total, and you know it's total because it says total of, is 220. And that's in dollars. So now we need to change our snack packs to dollars. I know that my large snack pack is worth $5. I'm going to add that to my small snack pack, which is worth $3. Now I have a system of equations that I can solve. So, step 1, pick a variable. I can pick any one I want, and I'll get the same answer. I'm going to go ahead and solve for x, which means I'm going to minus y. So I get 60 minus y is equal to x. So that's step 2. Step 3 is to substitute. So I'm going to take that and substitute it in for x. So 220 is equal to 5 parentheses plus 3 y. 60 minus y. Inside we get 220 is equal to 300 minus 5y plus 3y. Time to combine like terms, which gives me negative 2y minus 300 from both sides. I'm at negative 80 is equal to negative 2y. When I divide by negative 2, I get 40 is y. Okay? So 40 is y, which means 40 is my small snack pack. So I sold 40 small snack packs. Okay? Well, step 5 says to substitute into the other answer, and it's pretty easy to see that if I sold 40 small snack packs, that I must have sold 20 large snack packs, okay, because there are 60 total. But that's not entirely necessary, because the question only asks how many small snack packs did the snack bar sell. So they aren't interested in the large ones, they just want to know how many small snack packs did they sell, which is 40. So that's our answer, although this is a gridded response question, which means we need to fill it in. Now in a gridded response, remember you always fill it in from left to right using the pieces you need. So first column is a minus sign. Don't have a minus answer, so I'm not even going to touch it. Second one, I'm going to need a 40. So I'm going to circle in my 4. All right, 4. I'm going to circle in my 0. All right, 0. The rest of it, I leave blank because I don't need it. All right, so that's my gridded response answer. All right, here's one for you to try. If you need help, refer to your notes and the previous problem. All right, problem 4 says we're going to deal with systems that will have either no solution or infinitely many solutions. All right, so let's start with A. So A has x equals. Right, so x equals, that probably tells me that I'm going to take care of step 1 and step 2 in one fell swoop. So x is the one I'm going to solve for. Then I need to substitute. So I'm already on step 3, 3.5. That's my x plus 7y is equal to 14. Let's plug in what x is equal to, plus 4. There we go. 3.5 times 2, well, that's negative 7y. 3.5 times 4, I believe, is 14. Something like this. Now, what happens when I combine like terms on my y's? They're going to cancel out because we have a negative 7 and a positive 7, which cancel out, leaving me 14 is equal to 14. Well, when is 14 equal to 14? 14 is equal to 14 always. So, if you had to guess, is this one no solutions or is it infinitely many solutions? I'm going to lead towards infinitely many solutions. And in fact, anytime you have a number is equal to itself with no variables at all, it's going to be infinitely many solutions. Okay, and we can use infinity sign. I abbreviate it with SOL, but that's how we'll write it. All right, now I'm going to give myself a little bit of room to solve the next one. So, next one, step 1. Well, I already have y by itself, so step 1 and 2 are done for me. Step 3 is to substitute. I'm going to substitute this in for that y. So I have 3x minus 11 minus 3x equal to negative 13. Again, it looks like my x's will cancel off, which is a telltale sign that you're going to have an infinite or no solution problem. Now we get to this point, we have negative 11 is equal to negative 13. Now, unlike the last problem where we had something that was true, this is not true. Negative 11 is not equal to and will never be equal to negative 13, which means I have a no solution problem, no sol. All right. Here's one more for you guys to try. This just says how many solutions does the system have, so it's either going to be 0 or infinite. And here's your homework on page 371. Thank you and enjoy.